In this video, we are going to discuss classification of organic compounds. So this is in fact the first classification of organic compounds. So all organic compounds based on carbon framework, they are classified into two types. The first category, acyclic. Acyclic are open chain compounds. That means here the carbon chain is open. Carbon chain is not closed. So that is acyclic. Acyclic are open chain compounds. The second category, cyclic, or it is also known as a closed chain or ring compounds. So carbon framework, if you observe, it will be a closed chain. Whether it is a 6-membered ring or 5-membered ring or 4-membered ring, whatever it may be, carbon framework, if you observe, it is a closed chain. Carbon chain is closed. These cyclic compounds are further classified into two categories based on one property, that is aromatic nature. Whether the given cyclic compound is aromatic or not. How to identify aromaticity in later videos we will discuss. At this moment, you need to remember some examples under aromatic compounds. The cyclic or closed chain compounds which are not aromatic are said to be alicyclic compounds. This is the very important thing. It is not acyclic, it is alicyclic. Alicyclic, that means they are cyclic compounds but they do not possess aromatic character. These alicyclic compounds are further classified into two types. They are homocyclic and another one is heterocyclic. Homocyclic or carbocyclic, that means here the ring is made up of only carbon atoms. Ring is made up of only carbon atoms. No other element present in the ring system. Maybe it may be present in the side chain, but the ring is made up of only carbon atoms. In that situation, that is called homocyclic. Second category in this, heterocyclic. Heterocyclic, the ring is made up of a carbon and other element is also present. So not only carbon, if other element is also present in the ring system, during the formation of a ring, if other element is also involved, then it is called heterocyclic compound, heterocyclic. And in case of aromatic compounds, these are further classified into three types. Benzenoid compounds, that means benzene ring is present in the structure, whether it is one benzene ring, two benzene ring, three benzene rings, whatever it may be. Non-benzenoid compounds, they are aromatic but benzene ring is not present. Third category, heterocyclic aromatic, same thing, that is aromatic compound but that is not homocyclic. Not only carbon, other element is also present. So at this moment, you need to remember some examples of aromatic compounds. In future videos like general organic chemistry, there will be one subtopic like aromatic, non-aromatic and anti-aromatic compounds. By applying Huckel's rule, you will be understanding how to decide whether the given structure is aromatic or not. In the beginning classes, in the beginning classification, it is necessary to remember some examples under aromatic compounds. So let us apply this particular classification. You can see the first one we are taking acyclic or open chain compounds. Acyclic or open chain. So in this you can see the first example here, the carbon framework, it is open chain compound. Here also you can see this is open chain compound. Carbon framework, this is open chain compound. Open chain compounds, these are called acyclic compounds. Of course, these are further classified into various categories based on functional group. We will talk about that particular class in the next classification. So these are all said to be open chain compounds or acyclic compounds. There are high chances for asking the questions like how many of the following are aromatic, how many of the following are heterocyclic. How many of the following are alicyclic, like that. So the basics should be very strong. You need to understand each and every term here. And the next one is a cyclic or closed chain compounds. So here the ring structure, carbon chain, you can see this is the ring structure. Here also you can see the carbon chain, that is ring structure. In fact, here also you can observe even this one. But the difference is here the rings are made up of only carbon atoms. Bond line rotations are given, but in this not only carbon, it is actually a 5-membered ring. In that, 4 are carbon atoms and 1 is oxygen, therefore it is said to be heterocyclic. Homocyclic, homocyclic, homocyclic and heterocyclic, all these are alicyclic compounds. These are not aromatic compounds, and these are alicyclic. Particularly this is homocyclic, these 3 are homocyclic, and this is a heterocyclic. And in case of aromatic compounds, already told you few examples you need to remember at this moment. They are benzene, aniline, naphthalene, tropone, furan, thiophene and pyridine. These are all aromatic compounds, no doubt about it. But here benzene ring is present. This is homocyclic, homocyclic, homocyclic. In fact, this is also homocyclic. There should be no confusion. Oxygen is present, but that is not the part of the ring system. But this is heterocyclic, heterocyclic, heterocyclic. These are heterocyclic aromatic and these are homocyclic aromatic. But here benzene ring is present, benzene ring is present, benzene ring is present. So these 3 are benzenoid aromatic and this is non-benzenoid aromatic. These are heterocyclic aromatic. So this is about the first classification of organic compounds.